In 1984, NASA astronaut Joseph P. Allen became a part of history in a way no one could have anticipated. Imagine this: a man floating in the vastness of space, completely untethered, maneuvering a massive 12,200-pound satellite with nothing but a jetpack-like device. It sounds like something out of a sci-fi movie, but this was reality. Allen was the first person in history to wrestle a satellite in outer space. The event wasn't just remarkable for the feat itself, but because it came during a rescue mission that would push the boundaries of human spaceflight, redefine NASA's space shuttle capabilities, and ended up becoming one of the most expensive operations in the history of the space agency. The mission was about more than just exploration or the science behind space. It was about saving something of immense value: two communication satellites, Palapa B2 and Westar 6. These satellites were supposed to serve an important purpose in the expanding world of telecommunications, but a simple technical glitch sent them off course, and they ended up stuck in the wrong orbit, unable to fulfill their intended function. And who would pay the price? The satellite owners, of course, but there was more at stake than just their money. The entire satellite insurance industry in the 1980s was on the line, and that's where this rescue mission came into play. Lloyd's of London, one of the oldest and most prestigious insurance markets in the world, had insured these satellites. So when the satellites were rendered useless, the underwriters at Lloyd's, a collective of wealthy investors, were left to foot the bill. In the case of Palapa B2 and Wester 6, that bill amounted to a staggering $180 million in 1984 dollars. That wasn't just a financial hit for Lloyd's. It was a huge loss in the space insurance world. The underwriters, having paid out the insurance premiums, became the owners of the satellites. But these satellites were valuable in ways other than just their cost. They were still fully functional, and although they were stuck in the wrong orbit, they could be recovered and put to good use with a little ingenuity. That's where NASA came in. A solution had to be found, and quickly. The satellites were stuck in an orbit that took them between 150 and 600 miles above Earth, far lower than the intended 22,000 miles. To salvage these satellites, they would need to be moved back into a geostationary orbit. But how could that be done? The technology required was not available at the time, and there wasn't a way to move these satellites back into the right orbit without a monumental effort. But NASA, always at the cutting edge of space exploration, had a new tool at its disposal: the Manned Maneuvering Unit, or MMU. The MMU was an experimental jetpack-like device designed to give astronauts the ability to float freely in space. This was revolutionary at the time. Before this technology, spacewalks required astronauts to be tethered to their spacecraft. The MMU, however, was a fully functional propulsion system, allowing astronauts to move in any direction with ease, providing them with unprecedented freedom of movement in the vacuum of space. The astronauts would control their flight using two joysticks, one to control their rotation and another to direct their movement up, down, and all around. For the first time, astronauts would have complete freedom to move from one object to another without being constrained by tethers or the need to rely on the shuttle's robotic arms. The MMU allowed astronauts to travel from the shuttle to the satellites, making this rescue mission entirely possible. When the mission was designed, it was nothing short of a bold venture. The Space Shuttle Discovery would launch on November 8, 1984, marking the beginning of NASA's first-ever rescue mission. The task seemed nearly impossible, moving two satellites that were stranded in the wrong orbit, high above Earth. But the astronauts on board were ready to take on the challenge. Joseph Allen and Dale Gardner were selected to carry out the rescue, with Allen being tasked with using the MMU to retrieve the Palapa B2 satellite. Gardner would be ready to assist Allen during the operation from the shuttle's payload bay. A new tool was developed for the mission called the Stinger. This was a grappling device designed to capture the satellite and allow the astronauts to maneuver it back to the shuttle. The Stinger would attach to the satellite's thruster nozzle and use a series of hooks to grip the satellite firmly, making it possible for the astronauts to grab hold of it and maneuver it. The plan was set, with the Stinger attached and the MMU working to maneuver the satellite back to the shuttle. NASA was ready to execute this high-risk mission. But like all space missions, nothing ever goes entirely to plan, and there would be obstacles ahead. The first step was to track down the Palapa B2 satellite. Using the shuttle's robotic Canadarm, they brought the shuttle within a few hundred feet of the satellite, which was floating 210 miles above Earth. The satellite had already been slowed down using its own thrusters, and the rotation speed had been reduced to just one rotation per minute to make it easier for Alan to grapple onto it. Alan would be the first to venture out into space using the MMU, while Gardner assisted from the payload bay. As Alan maneuvered into position to secure the satellite, he faced one of the first challenges of the mission. The sun's glare made it difficult for him to see the satellite clearly. Despite the challenges, Alan successfully attached the stinger to the satellite's thruster nozzle, allowing him to secure the satellite with the MMU's thrusters. With a firm grip on the satellite, he began the process of stabilizing it for the return trip. But just when things seemed to be going well, a new problem arose. The attachment hardware used to secure the satellite to the shuttle's robotic arm didn't fit. The dimensions of the satellite, specifically with its antenna retracted, had been miscalculated, and there was nothing for the Canadarm to grab onto. This meant the satellite couldn't be lifted into the payload bay of the shuttle using the robotic arm as planned. This was a setback, but the astronauts didn't back down. Instead, they improvised. Despite being only 5 feet 6 inches with a slender build, Joseph Allen used his background in wrestling to tackle the problem head-on. As a high school wrestling champion, Allen wasn't unfamiliar with the concept of using strength and technique to overcome obstacles. He quickly realized that the only way to get the satellite into position was to wrestle it by hand. Allen anchored himself with a foot harness, which allowed him to secure his feet to the shuttle while he used his hands to move the massive satellite. This was a remarkable moment in space history, a human being, in the vacuum of space, physically manipulating a 12,200-pound satellite while floating thousands of miles above Earth. It was a dangerous and highly challenging task, but Allen was able to control the satellite's movements without damaging it or the shuttle. With hours of determination and skill, Allen and Gardner succeeded in maneuvering the satellite into position. This was an extraordinary feat that would forever change the way NASA viewed space rescues, as well as solidify Allen's place in history. The mission wasn't over, however. The next day, the team set out to retrieve the Westar 6 satellite. This time, the process would be slightly more straightforward, thanks to better coordination and the correct fitting clamp. Using the same technique, Gardner was able to recover the Westar 6 satellite in less time and without the complications they faced with Palapa B2. But what was truly remarkable about this mission wasn't just the technical achievements or the money that was at stake. It was the fact that NASA had shown the world what human ingenuity and determination could accomplish in the unforgiving void of space. The success of the mission proved that the space shuttle wasn't just a vehicle for launching payloads into space. It was capable of much more, including rescuing valuable satellites and returning them to Earth. The world watched as these astronauts overcame obstacle after obstacle, demonstrating that, with the right tools, determination, and ingenuity, nothing in space was impossible. The success of the 1984 satellite rescue mission marked a significant milestone for NASA. It was a triumph of human ingenuity and technological innovation, proving that space exploration wasn't just about venturing into the unknown, but about solving real-world problems in the harshest environment imaginable. But while the mission's success was celebrated, it also left behind a legacy that would come with its own set of challenges. The extraordinary operation, which had cost an immense amount of resources and time, signaled both the potential and the limitations of space exploration as it existed in the mid-1880s. One of the key takeaways from the rescue mission was the potential of the space shuttle to serve as a versatile tool, not just for exploration, but also for satellite recovery. This was the first time NASA had demonstrated the shuttle's ability to retrieve operational satellites in orbit. While the shuttle had previously been used to deploy satellites, this mission proved that the spacecraft could also perform complicated and risky operations, like retrieving malfunctioning satellites and bringing them back to safety. However, there was a lingering question that loomed over the operation. Was this type of mission sustainable? The sheer complexity of the mission, the involvement of astronauts, the cutting-edge technology, and the risk factors all pointed to the fact that such operations were not cost-effective. The recovery of 2 satellites required enormous financial resources, so much so that the mission became one of NASA's most expensive at the time. The launch of the Discovery Shuttle itself, the MMU technology, the specially developed Stinger tool, the astronauts' time and training, all these factors contributed to a hefty price tag that left many questioning whether it was worth the cost. The price tag wasn't the only challenge, however. The success of the mission was also heavily dependent on the flawless operation of the shuttle's technology, and there were no guarantees that future missions would go as smoothly. The MMU, while groundbreaking in its capabilities, was not without its limitations. The technology was still in its infancy, and there were concerns about its reliability and safety for future space missions. Although the MMU had performed well during the rescue mission, it was clear that it would need further development before it could be used for any large-scale operations. Despite these challenges, the mission succeeded in proving the worth of the shuttle as a multi-purpose vehicle. It was a shining example of how NASA had come to realize that the shuttle could do far more than just deliver satellites into orbit. It could recover them, repair them, and bring them back to Earth. The space shuttle had become an indispensable tool in NASA's quest to push the boundaries of what was possible in space exploration. Yet the rescue mission also inadvertently marked the end of an era for NASA. Just a few months later, in January of 1986, the world would be shaken by the tragic explosion of the Space Shuttle Challenger shortly after takeoff. The Challenger disaster was a devastating blow to NASA, one that forced the agency to rethink its strategy for human spaceflight and the future of shuttle missions. The Challenger disaster was a turning point for the space program. After the accident, NASA was forced to ground its shuttle fleet for nearly 3 years as investigations took place and reforms were implemented. The agency would face increased scrutiny over the safety of its space missions and be forced to reconsider its approach to space exploration, shifting its focus toward other critical projects. In the aftermath of Challenger, the space shuttle's role as a multi-purpose vehicle, capable of performing satellite rescues, was significantly reduced. The shuttle program, once seen as a vehicle capable of revolutionizing space travel and exploration, was now viewed with more caution. NASA moved away from high-risk operations, like satellite recoveries, in favor of more essential, low-risk missions. While the shuttle would continue to be used for scientific research in deploying satellites, the daring rescue missions that had defined the shuttle's early years were no longer deemed viable. Yet despite the Challenger disaster and the subsequent shift in NASA's priorities, the 1984 rescue mission remained an important moment in the history of space exploration. It proved that humanity had the capacity to adapt, innovate, and solve even the most complex problems. The astronauts who participated in the mission, Joseph Allen and Dale Gardner, became symbols of the pioneering spirit that defined NASA during the 1980s. Their bravery, creativity, and determination in the face of unprecedented challenges showcased the very best of what humanity could accomplish when working together in space. The Space Shuttle program, despite its later controversies and the eventual retirement of the fleet in 2011, continued to inspire a generation of scientists, engineers, and explorers. The lessons learned during the 1984 satellite rescue mission helped shape NASA's future endeavors, including the development of the International Space Station, ISS, the Mars rovers, and the Artemis program, which seeks to return astronauts to the moon. The satellite recovery mission also underscored the importance of international cooperation in space. The two satellites, Palapa B2 and Westar 6, were owned by companies from different countries. The cooperation between NASA, the insurance market, and the satellite owners highlighted the global nature of space exploration. It wasn't just about national pride or technological advancement. It was about finding solutions to challenges that affected people across the world. NASA's role in this mission went beyond just technological feats. It was also about protecting commercial interests, advancing space technology, and strengthening international relationships. The Space Shuttle program, which had been designed to reduce the cost of access to space, was now being used for a mission that blended both public and private sector goals. The line between government space agencies and private companies was becoming increasingly blurred, with each benefiting from the other's expertise and resources. As for the astronauts involved in the mission, their efforts were recognized as a significant achievement in human spaceflight. Allen's ability to wrestle the Palapa B2 satellite in space became the stuff of legend, cementing his place in space history. But it wasn't just Allen's heroics that earned praise. It was the teamwork, the planning, and the unrelenting pursuit of success that made the mission a triumph. The collaboration between Allen, Gardner, and the NASA engineers on the ground was a testament to the power of collective human effort and ingenuity. The mission's success also sparked a renewed interest in satellite recovery, which would later play a key role in the development of the space station and other future space operations. As technology advanced, it became increasingly clear that satellite repair and maintenance would be a crucial part of the space industry's future. And while NASA moved away from using the shuttle for such operations after the Challenger disaster, the lessons learned from this mission were never forgotten. The 1984 satellite rescue mission remains a shining example of what NASA could accomplish at the height of the shuttle program. It showed the world that space exploration wasn't just about launching rockets and sending astronauts to the moon. It was about solving real-world problems and overcoming the impossible. As the years passed after the 1984 rescue mission, the legacy of the operation lived on in both the successes and the failures that followed. The satellite recovery mission was one of the defining moments of the early space shuttle program, encapsulating NASA's remarkable achievements during the 1980s. However, it also highlighted the challenges and complexities involved in maintaining the ambitious goals that the agency had set for itself. The Challenger disaster, though a tragedy, eventually led to significant advancements in space safety protocols and engineering practices. The loss of the crew was a painful moment for NASA, but it also acted as a catalyst for reform. After the accident, the shuttle program was overhauled, with an emphasis on safety becoming a primary concern. This shift in priorities affected the way NASA viewed high-risk missions, and as a result, satellite rescue operations were put on hold for the foreseeable future. NASA's focus after the Challenger disaster was primarily on reducing the risks associated with human spaceflight and ensuring that the space shuttle was used for missions that were deemed to be lower risk. The tragic loss of the Challenger crew reinforced the need for greater caution when it came to launching and operating the shuttle. This meant that some of the more daring and ambitious missions, such as satellite retrieval, were no longer viable in the immediate aftermath. However, this does not mean that the 1984 rescue mission was forgotten. The mission had proved that NASA could perform extraordinary feats of space engineering, and the tools developed for it, like the MMU and the Stinger, represented significant steps forward in space exploration. Although the MMU was retired after the Challenger disaster, the knowledge gained from the mission continued to inform subsequent space operations. In particular, the 1984 mission played an indirect role in the development of the International Space Station, ISS, which would go on to become one of NASA's most ambitious projects. The station required the ability to repair and maintain satellites in orbit, something that the 1984 mission had pioneered. Though the space shuttle's role in satellite recovery was essentially phased out, the lessons learned about maneuvering in space, repairing delicate equipment, and working in a weightless environment helped shape NASA's approach to the ISS. The ability to service and repair satellites in space would become a critical function of the ISS in the years to come, and the technology developed during the satellite recovery mission laid the foundation for this new phase of space exploration. The 1984 satellite rescue also proved the importance of astronauts' ability to adapt to unforeseen challenges. Joseph Allen's remarkable feat of physically wrestling the satellite into position demonstrated not only his technical skill, but his creativity and resourcefulness in the face of adversity. In space, where the laws of physics are unforgiving, a simple miscalculation or misstep can have disastrous consequences. Yet Allen and his fellow astronaut Dale Gardner proved that human ingenuity could overcome even the most difficult obstacles. Their ability to think on their feet, to innovate, and to perform a task that had never been attempted before was a testament to the spirit of exploration that drives NASA forward. Looking back, the 1984 mission also serves as a poignant reminder of the risks involved in space exploration. While the mission was ultimately a success, the astronauts faced significant dangers as they maneuvered outside the shuttle and interacted with complex, delicate satellites. The challenge of performing spacewalks and working in an unforgiving environment where there is no room for error has always been a part of NASA's missions. The high-risk nature of space operations would continue to be a defining characteristic of the agency's work, but so too would the unrelenting drive to push the boundaries of human knowledge and capability. The decision to retire the MMU after the Challenger disaster marked the end of an era for NASA's Space Shuttle program. The MMU, while a brilliant piece of technology, was deemed too dangerous and complex to be used regularly. As the shuttle program moved toward more routine missions, NASA began to focus more on the scientific research that the shuttle could perform, rather than high-risk operations like satellite recovery. The end of the era of daring rescue missions, however, did not signal the end of NASA's exploration efforts. Instead, the agency shifted its focus to new, exciting frontiers. NASA's retirement of the Space Shuttle program in 2011 was a bittersweet moment for many. While the shuttle had been responsible for many of NASA's groundbreaking achievements, it had also faced its share of setbacks and tragedies. Yet despite the end of the shuttle era, the legacy of the 1984 satellite rescue mission lived on. It was a reminder that, despite the setbacks and challenges faced by NASA, the agency had the capability to achieve the seemingly impossible. The satellite rescue mission had shown that human determination and technological innovation could triumph over adversity. It was a moment in history that will never be forgotten, not just for the astronauts who performed the daring feat, but for the millions of people who watched in awe as humanity reached new heights in space exploration. In many ways, the rescue mission was a precursor to the future of space exploration. It showed that space missions could involve more than just launching rockets and exploring distant planets. They could be about problem-solving, adapting to challenges, and working together to solve complex issues that affect not only astronauts, but also businesses and nations. The ability to recover satellites in space, repair malfunctioning equipment, and ensure that vital assets are protected would become an essential part of the future of space exploration. And while the MMU itself may have been retired, the concept of space repairs and satellite recovery would not fade away. In the years that followed, NASA's work on satellite servicing would evolve into the space robotics and satellite servicing technology used on the ISS and in other missions. Innovations like the robotic arm on the ISS and the use of drones for satellite servicing are all rooted in the lessons learned during missions like the 1984 rescue. For many, the 1984 satellite rescue mission remains a symbol of NASA's pioneering spirit and its ability to innovate in the face of seemingly insurmountable challenges. The mission was not just a success in terms of its technical achievements, but also a testament to the unwavering resolve of the astronauts who participated in it. Joseph Allen, in particular, would forever be remembered as the astronaut who wrestled a satellite into position in space, a feat that continues to inspire those who dream of one day traveling beyond our planet. Ultimately, the story of NASA's most expensive rescue mission is not just about the technological innovations or the challenges faced by the astronauts. It is about the human spirit of exploration, the drive to push boundaries, and the belief that, no matter the cost or difficulty, there is always a way forward. It is a story of triumph, perseverance, and the unrelenting desire to solve problems and make the impossible possible. And as we look to the future of space exploration, it is clear that the lessons learned from this mission will continue to inspire generations of astronauts and engineers as they reach for the stars.